Hello, the purpose of this video is to show you how to take your raw titration curve data and to extract information about it relevant to the equivalence point. So at this point you should have your raw data that you collected in lab, and it should look something like this with a series of columns and a bunch of numbers. What we're going to need to do is extract some information from these data. So I have a table here that I've set up to show you the information that you're going to extract from these data. We're going to need to know the volume of NaOH that it took to reach the equivalence point, and then the corresponding pH. We're going to calculate the volume of NaOH to get halfway to the equivalence point, and then the pH at halfway to the equivalence point. And the reason why this is relevant is because the pH at halfway to the equivalence point corresponds to the pKa value of the acid that you're working with. In this case, it would be KHP, potassium hydrogen phthalate. Okay, so the first step is to take our data, and we have to do a couple of housekeeping tasks on here. The first step is to take these columns and adjust their width so that we can read what's on them. So to do that, all I'm going to do is highlight the columns by clicking up here and holding and then dragging over to include all the data. Then what you do is you take your mouse and you go in between the two columns, and if you notice there, when you hold it right in between, it turns into a double-headed arrow with a line in the middle. What you're going to do is double click on that, and what this does is it automatically adjusts the width of the column so that you can see everything that's on there. The next step is we have some columns in here that we don't need that we're going to get rid of. The columns include information about the second derivative. So we're going to get rid of it by clicking at the letter at the top of the column. In this case it's D. You're going to right click and then you're going to select delete. And there it goes. Okay, I've got another one right here. Delete that. And then I have one more over here. I'm going to delete that. Okay, the next step is to take all of these values here and adjust the decimal place so that we are including numbers only up to the extent that the instrument can read reliably. So to do that, I'm going to take and highlight all of the numbers going all the way down. And the nice thing is we can do this all at once. So I've highlighted all of my numbers, and I'm going to go up right up here, where we have a button that says increase decimal, and then we have one that says decrease decimal. We want to decrease the decimal. So I'm going to hit it, and you'll notice that now all the values here have the same number of decimal places, and I'm going to continue to press it until we get to 2 decimal places. There we go. Okay, the next thing I'm going to do is I'm going to make it so that this top row is always visible. So I'm going to go to View, and we're going to go to Freeze Panes, and I'm going to go to Freeze Top Row. There we go. No matter what, when we scroll, it'll stay up there. Okay, the next step is to create a titration curve that includes all of the information for this trial here. Now, on Logger Pro, it shows your last trial as the latest one, but we're going to make it a little bit simpler and we're just going to refer to this as the first trial. So this is going to be trial 1, even though it's technically not. It doesn't really matter. So what we're going to do to create this titration curve graph is to highlight the columns here. So this is the volume, the pH, and the first derivative columns here. And notice that I'm just selecting the numbers. I'm not including the labels at the top of the columns. So I'm going to select them and go all the way down. Okay, we've got all our data selected for our first trial. I'm going to go to Insert, and then we're going to go to this graph right here, the XY scatter plot, and then we're going to select the first option. So now we have our titration curve. We have our volume of NaOH added on the x-axis, and then we have a y-axis with 2 different values on it. So we want to include a secondary y-axis so that we can have 1 for the pH and then we can have 1 for the first derivative. So to do that, to add a secondary axis, what you're going to do is you're going to right-click on anywhere on the graph here, and you're going to select Change Chart Type. And now we have all these options. We're going to go to the one at the bottom, which says Combo. And so now we have Series 1, which is pH. We have Series 2, which is the first derivative. And basically, we want both of these to show up as a scatter plot. So I'm going to go to Chart Type, and I'm going to scroll down to get XY scatter. And then I'm going to go to the next one, and I'm going to do the same exact thing. There we go. So we want the second series, the first derivative series, to show up as the secondary axis. So I'm going to put a check mark next to that. And I'm going to hit OK. All right, so now we've got a y-axis for the pH, and then we have a y-axis for the first derivative. Now we need to insert some labels here because, as you can see, it's getting a little bit confusing. So I'm going to go to Quick Layout up here, and this is under the Chart Design tab. And I'm going to go to the first option and click that. So now we have a label for the title, we have a label for the first y-axis, and we have a label for the x-axis. However, we don't have a label for the second y-axis, so we need to insert that. So we need to go back up here to Chart Design, and we're going to go to Add Chart Element, and we're going to go to Axis Title. We're going to select Secondary Vertical. And there it is. Now we have a box that we can use to label everything. The first step is to give the chart a name, a title. So this is going to be the titration curve for NaOH and KHP. And this is we're going to call this trial 1, even though it's technically not. It doesn't really matter what we call it. Trial 1. On this axis, we have pH, so that's what we're going to call that. On this other y-axis, we have the first derivative. Now, pH doesn't have a unit, so it's just labeled as pH. The first derivative technically does, but we don't need to worry about it, so we're just going to call it first derivative. And then on the x-axis here, we have volume of NaOH, and it's in milliliters. The final thing I want to label is I want to make it clear that the blue line here, the blue data points, refer to the pH, and the orange data points refer to the first derivative. So to do that, you're going to go anywhere on the plot area, right-click, and you're going to go to Select Data. So now we have Series 1, Series 2, and what I can do is edit it, where Series 1 is going to be called the pH, and I want Series 2 to be called the first derivative. And you can see that the graph updates itself with the labels I just gave it. All right, now what we're going to need to do is hold the mouse over a special point on the first derivative graph. So what I'm going to do is go over here with my mouse, and I'm going to hold it right over the highest first derivative point. This is the point on the pH curve that has the highest rate of change of pH, and that corresponds to the equivalence point. So if I hold the mouse on this highest point right here, you can see that it's labeling the x value and the y value. The x value is 5.07, and that's milliliters of NaOH. And so this corresponds to 5.07 milliliters of NaOH. And what we're interested in is the pH at this point. So what I need to do is go back to the raw data and find 5.07 milliliters of NaOH and record the corresponding pH. Okay, so the volume is in the first column here. So again, I'm looking for 5.07 milliliters. And there it is right there. So the corresponding pH is 8.33. I'm going to go back up to my table here that I made at the beginning, and I'm going to record 8.33, and this was for, I forgot already, 5.07. Just wanted to make sure. So 5.07 milliliters. All right, the next step is to look up information at halfway to the equivalence point. And the reason why this is important is because this corresponds to the pKa of the acid that you're working with. So the first step is to calculate the volume halfway to the equivalence point. So essentially, we want to find out what half of this number is. So to do that in Excel, you type equals, you click on the cell, and then you're going to divide by 2. So we get 2.535. And I'm just going to adjust the decimal place in the correct direction. And we're going to look for 2.54 and find the corresponding pH just like we did a minute ago. So we're looking for 2.54 milliliters. Okay, there it is. And then the corresponding pH is 5.25. This corresponds to the pKa value of the acid, which in this case is KHP. I'm sorry, I already forgot it as I was talking. 5.25. 5.25. Okay, so I have completed the extracting the data for trial 1. What you're going to need to do is generate another curve for your other trials. So if I move this out of the way, what you're going to need to do for the next trial, which starts right here, is to take and highlight this data and go all the way down and essentially just follow the same steps that we did to generate the first graph.